Welcome to an educational video explaining some of the positive and negative feedback loops in the Earth's climate system. Planet Earth formed 4.5 billion years ago, along with other planets in our solar system. Earth, however, is unique as it sustains life. Life on Earth started to appear approximately 4 billion years ago. Over this time, a series of feedbacks within the Earth's climate system have been vying for dominance. On a number of occasions in Earth's history, the system has been in balance, allowing different life forms to evolve. In this video, I'm going to explain some of the feedback loops, both positive and negative, that affect Earth's climate. Positive feedbacks are often referred to as reinforcing feedback loops. Negative feedbacks are often referred to as balancing feedback loops. Feedback loops can either amplify changes in the case of positive or reinforcing loops, or dampen changes, as is the case for negative or balancing loops. When one kind of feedback loop dominates another, it's known as shifting dominance. The climate on planet Earth is made up of complex and interconnected systems, which for most of the Holocene, the last 11,000 years, have been carefully balanced. In this regard, they're said to have dynamic equilibrium, a stable state. Firstly, I will address positive or reinforcing feedbacks, an example of which is here on the left. These amplifying feedbacks often make Earth system less stable, pushing the system further away from its original state. Feedbacks, both positive, represented by the addition sign, and negative, represented by the subtraction sign, are often shown using diagrams such as these. These are called causal loop diagrams. One of the most important positive feedbacks on Earth involves water. As the atmosphere warms, it can hold more water vapor. Since water vapor is a potent greenhouse gas, this amplifies the warming effect caused by other greenhouse gases, such as CO2, creating a reinforcing feedback loop that intensifies the initial temperature increase, and a cycle, sometimes referred to as a vicious cycle, repeats. Another example of a reinforcing feedback loop is the ice albedo feedback. As the Earth warms, Arctic, Antarctic and glacial ice and snow are melted to reveal dark ocean or land. With the ice and snow gone, which once reflected sunlight and heat, the dark ocean and land now absorbs yet more warmth, thus forming a self-reinforcing or positive feedback cycle. Negative balancing feedbacks work by dampening the changes and work to stabilize the system. An important negative feedback in the Earth system is cloud formation. Clouds blanket the sky and reflect sunlight back into space, cooling the Earth and helping to counteract the initial warming. The Earth's ocean systems also act as a balancing feedback by their ability to draw down carbon dioxide out of the atmosphere and store it as bicarbonate in the ocean interior. A recent study published in Nature Communications found in 2010 alone, 3 gigatons of carbon were drawn into the oceans, about a third of greenhouse gas emissions caused by human activities. Another balancing feedback in the Earth system is vegetation's ability to store carbon. Plants and soil, for example, can remove CO2 from the atmosphere, thus cooling the Earth. As mentioned at the beginning of the video, Earth has supported life in many forms for approximately 4 billion years using feedbacks such as these. However, since the beginning of the Industrial Revolution, human activities such as burning fossil fuels and deforestation contribute significantly to positive feedbacks, accelerating climate change and warming planet Earth. Some of the positive and negative feedbacks discussed in this video can be seen on this expanded causal loop diagram. Over the past 150 years or so, feedbacks have shifted dominance so that the reinforcing feedbacks are the most prominent. If these dominant feedbacks continue, Earth is likely to reach a tipping point, moving from a relatively stable Holocene-like state to a hothouse Earth-like state. In conclusion, positive and negative feedbacks play a crucial role in the shaping of our planet's climate, while positive feedbacks can amplify changes and pose challenges. Negative feedbacks provide a natural regulatory mechanism. As we strive to address climate change, it is essential to consider these feedback mechanisms and work towards a more sustainable future.